Okay, so we're on page 361. Let's look at number 1 on the Did You Get It? As of February 2017, $1 equals 8100 British pounds. Write an equation to give the number of British pounds Y you would receive in exchange for $0. Then use the equation to find the number of British pounds you would receive if you exchange $50. So we see that the British pounds that you would get is going to depend on the number of US dollars. Okay, so it looks like $1 is equivalent to 8100 British pounds. So let's see if this would make sense. $0, oops, that's US dollars, British pound. So $0 would give us 0 British pounds. $1 would give us 8100 British pounds. Yeah, that equation feels good. Now, you didn't have to do that table like I just did. It's just a good way to double check your answer to make sure that you're right here. Okay, so my equation is up here, and I will use that to figure out how many US dollars I will get for, sorry, how many British pounds I will get for 50 US dollars. So 8100 times 50, 40.5 British pounds. Okay, so I'm going to get rid of this table real quickly. All right, so this has a nice summary of direct variation. You really need to study this. This is great. So the following are various ways of illustrating what it means to say two variable quantities vary directly. One of the things verbally, they will say that one quantity varies directly as the other. It's right here, okay? And the constant of variation is, well, usually we have to figure out what that K is. Algebraically, your formula will always look like this. You will have to figure out what the K is. That K is going to be some sort of number. So that's why they give you this following example. Numerically, I think we're going to notice here that if something doubles with the x's, you notice how the y's double as well. So, yeah, that's another way to see that it varies directly. Also notice that graphically it is a line that goes through the origin. So any line that goes through the origin, that is a direct variation problem.